We've gotten to this part of the problem. This is part C, again from 2014 with a couple of additions to it. So we've got h of x equals to g of x over 5x. So that requires the derivative there. And so we set the derivative. Now is the point where we get to plug in the actual value 3. Again, don't plug in the 3 too early, because if you do, you'll see 5 times 3 is 15 and the derivative of 15 is 0. So you want to make sure you get it done like this first. So we've got 5 times 3 times g prime of 3 minus g of 3 times 5 over 5 times 3 squared. Okay, well, here we are. 5 times 3 is 15, so you got g prime of 3. Now g prime, remember, g prime would equal to f. So f of 3 is looking like it's going to be negative 2. All right, minus g of 3. And g of 3 is the value we found in part A. I've erased that from the board, so I'm going to have to resolve it. So we've got the area inside of this triangle here, which is 2 times 5, which is 10 minus 1 is 9. So g of 3 is 9. So we have 9 times 5. And then 5 and 3 is 15. You square 15, you get 225. So now in the numerator, we get negative 30 minus 45 over 225, which would be negative 75 over 225. Now again, we don't need to go about simplifying this. If you get to that point right there, you're good. So that would be your h prime of 3, which was part C to this question. Part D to this question, I have started set up right here. We've got f of x, p of x, and p of x is f of x squared minus x. So its derivative is the derivative chain rule, so it's f prime of x squared minus x, then times the derivative of x squared minus x, which is 2x minus 1. So at this point right here, now we go into the point, what's it asking about? Well, it's not on the board here, but it's on your sheet. We want to know when x is negative 1. So we've got p prime of negative 1 is f prime of negative 1 squared minus 1, then times 2 times negative 1 minus 1. All right, so this becomes 1 minus 1, which is 0, so we want to know what f prime of 0 is. And then this is negative 2 minus 1 times negative 3. So f prime of 0, we have to go over here and find the slope of this graph f at 0. So it's undefined here. So for that very reason, this answer right here will be undefined. The last part is they define j of x as being the integral of 0 to x of f of t dt. And from there, we want to determine the limit as x approaches 0 of f of x minus f of x over x, sorry. All right? Or j of x, sorry, j of x. So we want to know the integral from 0 to 0. Well, that's going to be 0. So we get 0 over 0, which yields an indeterminate form of 0 over 0. So we go to L'Hopital's rule. which says we want the limit as x approaches 0 of j prime of x over x, which is, I'm sorry, over 1, because the derivative of x is 1. So j prime of 0 is f of 0 over 1. And f of 0, we go back over here, we see f of 0 is 4. So we've got 4 over 1, which is 4. So the answer to part D, or part E, which was the additional part, is 4.